Okay, we're live, so I guess we'll start with the instructions. Do I think we did before? Okay. So it says here, ensure that each team member, this is number 2, ensure that each team member understands how to complete the square to find the transformational vertex, the vertex form of a quadratic equation, and check your answers to their prep questions, and discuss the theorems from the preparation assignment, ensure that each team member has the right answer for the questions. Okay, I'll pull up a Word document.
Chris,
yeah.
Before we get ahead of ourselves, it looked like it said that we should say a prayer.
Oh.
To start it off. I just now saw that.
Sure.
Above team discussion. Yeah.
Yeah, at the beginning of each, yeah. So I guess, Jeremy, would you like to say the prayer since you...
Sure, I'll say it.
Thanks.
Yeah. Our dear Heavenly Father, I'm so very grateful for this opportunity that I have to be here on this Google Hangout on air to be able to talk about different things that we have to do today for this Math 109 course. Please bless us, so we'll be able to have the Spirit with us as we help each other to be able to understand the material and understand what we need to know for the tests coming up. We ask and pray for these things humbly in the name of Jesus Christ. Amen.
Amen. Thank you.
You're welcome.
Okay, yeah. So I will pull up that Word document that I created that has the preparation stuff. If I can find it. Yes, here it is. Okay, so 1, 2, 3, and 4 here are the preparation assignments, so I guess we could just go through those. So 1, it has this equation and asks you to convert it to the vertex form, which is this. And we know from the vertex form that H and K are the vertex, which would be H and K. But I wasn't sure if there should be -1s because it's possible one here because in a parentheses. Does anybody have any thoughts about that?
So
yeah, go ahead.
Yeah. Okay, so when it's in the parentheses like that, when it's H, you do, I believe you do the opposite because you have to find what X equals.
Oh, yeah. Makes sense.
All right.
So then it would be indeed 1, 4. Yeah. And now we have to find the x-intercepts. So I believe to do that, we want to set the x's to 0, but I'm not sure.
No, you need to set y's to 0.
The y's to 0.
Okay, so just 1 y.
Right. So 2x squared minus 4x plus 6. So, okay, and then we'll subtract 6 from both sides. -6 equals 2x squared minus 4x.
Hey, Chris.
Yeah?
You could just do it from the, what is it called? Quadratic function. form that you have it already right there.
That the vertex, yeah.
Yeah, so if we just set y to 0, then it would be, let me just solve for x with that one. And I feel like that would be a little bit easier than doing
Going
all
back
of
and
that
forth.
again from
Yeah.
the original form.
Makes sense. Oh yeah, so that would be -4 plus 2x minus 1 squared. There we go. That makes sense. You have to divide both sides by 2. That'd be -2 equals x minus 1 squared. That's why that's not. And then wouldn't you have to square root both sides? Yeah.
Yeah.
Yeah, so then you would have plus or minus square root in the answer. So that's how we're going to get both of our answers for x, or I guess the two
right.
x-intercepts.
Plus or minus the square root of x minus 1?
No.
Yeah,
No,
no.
that doesn't sound right. There's something we're missing.
That's 4. Okay, so
Wouldn't we use the difference quotient for this? Or not the difference quotient, the quadratic formula with minus b plus or minus the square root of b squared.
Yeah,
So-
but when you have complete square, and when you take square root of it, it just stays x minus 1.
Oh, okay.
Squares x square root.
Because you're square rooting the -2, but the square just gets canceled out on the x minus
Yeah.
1.
Oh,
That
right.
makes
You're
sense.
right. I messed up there. So it's plus or minus the square root. Oops. Sorry about that. It's plus or minus the square root of -2 equals x minus 1. There we go. And then you have to add the 1 over there.
yeah.
Mm-hmm.
So the x-intercepts are plus or minus, or 1 plus or minus square root of -2.
Of -2. Good to me.
So you can't find the square root of negative number unless you're using imaginary numbers, and I think they want the answer in terms of imaginary number.
Oh.
So then it would be 1i plus or minus the square root of 2. Is that correct?
Yes, because I equals to square root of -1.
So you said, what did you say?
1i
Yeah, 1i
plus or minus the square root of 2.
plus or minus the square root of 2. Yeah, that's right.
It would be 1 plus I plus or minus I square root of 2.
Oh, sorry. That makes sense.
Because -2 is -1 times 2, and it's all under the square root. And so it's the same as square root of -1 times square root of 2. And square root of -1 is I, so it's in front of square root of 2.
Okay, that makes sense. I remember doing that in the homework. I just forgot just now. Trying to cover my tracks. And then we do the same thing right here with the original problem, but we put x is 0 to find the y-intercepts.
Okay, so you take the original equation.
Yeah. Well, I was going to say take the 2x minus 1 squared plus 4 the exact same way we did it with the x-intercepts, just do it with the y-intercepts.
If you just plug 0 in for
x, yeah.
For the first problem, it equals 6.
So make that a 0. Oh yeah, it's just 6, yeah. It's 2 plus 4 is 6. Yeah.
So the y-intercepts, isn't that supposed to be a coordinate pair?
Yes. So it would be 0, 0, 6.
Yeah.
This one would be this, comma, 0. Speaking. Okay. What were we supposed to do with this?
So that's just a new problem, and we're looking for the x-intercepts. Is that
I'm
correct?
trying to see what that is, just real quick.
All right.
No, this is still the prep. Where did I put the prep? Yeah, this is it. And okay, for number 3. Oh, we're doing the zero product theorem. Okay. Use the zero product theorem to find the x-intercepts of the following binomial. I forgot to add one. But yeah, we're going to have to find the x-intercepts of that. And I forgot to add this one right here. I'll type it out, I guess. Okay, that makes sense. Yeah, so we're trying to find the x-intercepts of this one, and then the zeros of this one.
All right.
So let's see.
Does it want us to just find the x-intercepts then?
Yeah, that's what it looks like.
So one of them would be 2, 0.
2, 0, yeah.
Yeah, and then
2, 0, and
3, 0.
3, 0, yeah. That was it.
And
Yeah, that was it.
then pretty sure if I'm not wrong, that's an x cubed. So it hits. Does it hit the x-axis 3 times then, or
Yes.
is it? Yeah. So it would also have one at the origin with 0, 0.
Yeah.
All right.
Oh, right.
So basically, when there is like x times, in parentheses, something x minus 2, you would just equal all of these things to the 0. X equals to 0, x minus 2 equals to 0, and x plus 3 equals to 0. When you multiply something by 0, it's always 0. So either x can equal to 0, either x minus 2 can equal to
0. Okay. That makes sense. Oh, yeah, so this one has to equal 0, this has to equal 0, and this has to equal 0. That makes sense. Okay. And then we need to find the zeros for this one. Any ideas?
So when it says find the zeros, are we trying to simplify it? Trying to remember.
Let's see. The zero product theorem. If A and B are an algebraic expression, then the equation AB equals 0 means that A equals 0 and or B equals 0. Use the zero product theorem to find the x just kidding.
We're on the rational roots theorem, right?
Yeah.
Yeah.
Okay.
That's actually that was confusing. Sorry, that was confusing. We're here. We're right here. That was really confusing. Sorry, guys. Okay. Rational roots theorem. If a function is a polynomial with coefficients such as a(n) does not equal 0 and a of 0 doesn't equal, then P over Q is a list of possible rational zeros, where P are the factors of the constant a and Q are the factors of the leading coefficient. Oh, right. That's right. So we have 3 and we have 16. We want to find all the possible that's backwards, isn't it? 16 over 3. I'm going to find all the possible factors of 16 and all the possible factors of 3. Three and 1. Two. Oh, there's 1. There's
Yeah, it'd be 1, 2,
2,
4,
4, 8,
8, and 16.
right? Okay.
Yeah.
Okay. So that translates to 1/3. Let's do that backwards. Makes a little more sense. Oops. So we have 1. We have 1/3. We have 2 2/3. 4 and 4/3. We have 8 and 8. Oops. 8 and 8/3. 16 and 16/3. Okay. And I think we want to set up some kind of synthetic division, if I'm not mistaken. Let's see. So we have that. And we have 3. We have 3. 3.
Here's some space you can use if you need it.
All right, thank you.
1, 16. So out here. Oh, right. We just add a little image here.
So we have 3x to the fourth, and then we have minus 2x to the second.
Oh, right. You're right.
Yeah,
You're
that
right.
x
You're
to the
right.
third
This
has
should be a
0.
0. That's right. You're right. Okay. Okay, that's better. So you bring down the 1. One plus 3 is 4. Four times 1 is 4. And that equals 4 again. Four times 1 is 4. Times 2 is 8. Oh, yeah, I guess I should organize that a little better. So we're all doing one of these numbers to find out which one's irrational. So how do we want to do this?
You multiplied the 2 and the 4 to get 8, but I believe you're supposed to add it, right? So it'd only be 6, and then that one plus 6 would be 7.
Wait a minute, what?
Right on the 2 and 4, you multiplied those two instead of just added it.
Oh, right. You're right. My mistake. Be 7. Oops. That would not be 7. Wait a minute. Yeah, that would be 7. That would be 8. 9 times 1 is 8.
So you're just adding 8 to 16, right?
Yeah.
Okay. Well,
Someone wants to put a bunch of 8s. I don't know why. Yeah. So we know this was not a root because $24 does not, and then yeah, so 24 minus 8 does not equal 0. So the idea, I guess, is you're trying to get a 0 right there. So how do we want to divide this up then?
what exactly are we doing?
So we're setting up the synthetic division to find the zeros or the rational roots. And
So then, are we putting those numbers that we just typed in back in the equation, or?
Yeah, you're going to get rid of all this and change that 1 to a 1/3 and then do it all again, then a 2, then a 2/3, then a 4, then a 4/3, and all the way until I get down to 16/3.
Okay. So are we just going to assign certain people
Where'd you get the 7 from underneath the 1? Because isn't it 1 times 6, and then it would be 6, and then you do 1 plus 6 is 7?
Yeah, you're right, man. Wait a minute. 6 I want to say. Right, that's 7. And then 7 times 1 is 7. Is 7. That makes that 23. Okay, so let's assign people, I guess, to do some problems. Okay. So James, do you want to do the 2 2/3?
Yeah.
And then Jerem, the 4 4/3.
Yeah.
And forget that all of those numbers, 1, 1/3, 2, are also minus. Like we can use minus negative numbers of those.
Oh, we can too? Okay.
Yeah.
So can you give me a quick rundown of what I'm supposed to do with those numbers? I'm
Yeah,
sort of lost right now.
Negative, negative, negative.
Oh, so I've got 2 2/3, but I've also got -2 and -2/3.
Yeah.
Okay.
Let me explain how the synthetic division works.
Can you move the screen back over so I can see the first couple numbers? Okay. Perfect. Thanks.
Okay, so I guess a quick refresher on synthetic division. So you pull all the numbers, the coefficients up, and you add a 0 there because, like, the TA, if you will, explain.
Oh, the
There's
X
4,
cubed.
3,
Gotcha.
2, 1, 0. So that should be a 0 out there for
Yeah.
the 3 spot. And then you take whatever number you have here and put it here. And then you immediately drop that number down here. And then add these two together, 4. Bring this number up here. Add these two numbers together to get 4. Put that up here. Add these two numbers together to get 6. Put this 6 up here. Add these two together to get 7, and so on.
Alright, that makes sense. I'll be right back. I gotta go use the restroom.
Oh, sweet. And then does anybody want to do the 16s? I guess I'll do
We can
the
just
16.
race and whoever gets there first. It's just +16 and -16.
It's +16, 16/3, -16, -16/3.
Okay, I will do my best.
All right.
Gotcha.
I apologize. What 2 numbers was I doing again?
You can do the 16. You can help with the 16.
Just plain 16, not negative?
You can help with all of them. 16, 16/3, -16, -16/3. Do as much as you can.
And then also after this one, since these are the preparation problems and we're supposed to do these by ourselves beforehand, I say we move on after this one since it's a lengthy one, to the extension problems, and then also to the group quiz that we have today since a couple of us have to leave early. So
Sure. We're just trying to review, you know.
no, I know, and it's good. It's a good review, and it's great help.
I'm
Us
glad.
just, since we have a group quiz that's
Yeah.
due today, and also the extension problems that we have to do. So
Yeah, sure.
and
Yeah,
I'm pretty
and-
sure that the extension problem has a couple of them here for the rational zeros theorem as well, which would help us keep practicing these. That'll actually be, graded
Yeah,
and
and
things.
in the question they just asked us to find possible zeros, not like solving it.
Oh, okay. My mistake.
So we don't have to solve all these numbers, or we do?
No, it's just what are the possible rational zeros for the following polynomial, and that's it.
So how do you find that then? Because that's how someone explained to do it to me.
Yeah, that's the way. You could do long division, I guess, if you know how to do that.
Yeah. That works too.
Yeah, but we can move on, I think.
Yeah, let's move on. Let's just move on. Sorry about that, guys.
Oh,
I
it's
was almost done with
No,
two.
At
it's
least
good
we're
review.
used
It's good
to
practice. So.
how to find errors.
Yeah, I have to leave in like, this is going to be awful. I'm going to go ahead and email Sister Hess because I have to go in like 5 minutes.
Yeah, sorry about that. Where the
Do you
heck
have
are they?
class or?
There's a, so normally I don't have class. Normally I don't do anything today, which is awesome. But today, Goldman Sachs is a financial company and they're here on campus. And I'm taking resume workshops and interviewing workshops with them today.
Oh, okay.
So it's not like a normal occurrence.
Man. Okay, yeah, sorry. Dum, dum, dum. Okay, why don't we do that then? Since you're gonna be gone in 5 minutes, why don't we do the group quiz? Does that sound good, to everybody?
Yeah.
Yeah, that works for me.
Do the group quiz. Do things a little out of order, so we can accommodate. Okay. Here's the group quiz right here. Okay. So find the x-intercepts of the quadratic equation y equals ax squared plus bx plus c by completing the square. And then what is the y-intercepts for the given quadratic equation? I guess we'll complete the
So
square.
which one's the given equation?
That one, I think.
All right.
Yeah, it's that one.
All right.
So x squared plus b divided by a.
So on this one, there's no numbers. We just have to do the equation with the other.
general.
Okay.
Yeah. Divided by ax squared plus b divided by a times c. Right. Okay. And then y equals x squared plus 1/2 ba. Oh, so a lot simpler. X plus. So would that be 1/2 ba then? Because we have this one, and it should be half of ba. Put it on
Yeah, it's
here.
half of BA.
So 1/2 ba. Squared. Yeah. Plus would be ba.
Question.
Yeah.
The 1/2 BA, we could do B over 2A squared. Would that be simpler? B over 2A.
Yeah, because you're just multiplying them. That makes
Right.
sense.
Yeah.
B over 2A. And we have over here, we have BA times C plus B over A, B over A. Excuse me. How do we factor or simplify that statement right there?
So I worked it out a little bit, I guess, and the answer that I got would be for the thing. I'm kind of lost of what you guys are doing right there. I've got A parentheses x plus B over A and parentheses squared minus half B plus C.
So
Is
to
that
find
correct?
So to find x-intercepts, you need to equal y's to 0, right?
Yeah.
And you would divide the whole equation by a. That's what you're doing, right?
Oh. Was I just making it? I was trying to complete the square, but that makes sense too. Equals or 0, I should say. Minus x squared.
You could use just quadratic formula. Do you know the quadratic formula?
Not by memory, but I could.
Minus
Negative
B
B plus or minus
plus or minus
square root B squared minus 4AC all over 2A.
And you will find x's, right? That's what you need to find.
Plus or minus.
Or you could also complete square and then do all of the things like we did in the last examples. And then you would find the same roots.
B squared.
That's longer.
Minus 4AC. Oops. All over 2A, right? So what were you saying that we should do with this quadratic formula then?
Yeah, when you use quadratic formula, you're finding x's, right?
Yeah.
And those are your answers. X-intercepts. When you are trying to find x-intercepts, you need to equal y's to 0. When you're trying to find y-intercepts, you need to equal x to 0 and find roots. So we found roots by just the quadratic formula. And then you could like write it as points.
Mm-hmm. So what would those points be? I'm a little confused.
So we equaled y to 0, right?
Yeah. Right there, yeah.
So instead of y, we would put 0 for sure. And then we have two answers for x's. So there will be 2 points.
So should we solve for this one then?
Yeah, we need to solve for this one.
Okay, I could do that. Minus C equals x squared plus bx. And subtract bx as well. Negative C minus bx.
But don't forget that we need to find x.
Oh, right. So it's C divided by x, divided by b, excuse me.
All right, guys. Sorry to do this. I gotta go. You can like dock me as many points as you want. But I'm gonna be late to this thing, so I gotta go.
Okay.
See ya.
Okay.
Yeah.
Yeah.
Okay. So then what would you do from there?
Well, you take the.
When you're dividing by b, you need to divide both sides. And remember how in the last example we tried to complete the square?
Mm-hmm.
So it's like basically the same. It is the same as 2x squared plus 4x plus 1, for instance, equals to 0. And you need to solve this. So to solve this, you would either use quadratic formula, which you wrote down here, minus b plus minus square root of, or you could complete square and then find x's by completing the square. Either way.
Okay, I guess.
So with completing the square, it's half of b squared, or plus.
Yeah.
Plus, and you add it and you subtract it, so it doesn't affect the other side.
Can you
Right.
explain that again?
So with the x squared plus bx plus c,
Uh-huh.
you take half of b and
Uh-huh.
you square it.
Oh, right. X plus b half
b over 2.
squared. Okay.
Yeah.
And then b.
And then when you open x plus b over 2 squared, it would be x squared plus bx plus b squared over 4, meaning that you added b squared over 4 and you need to subtract it.
And squared. X squared plus, what did you say? 2.
So
yeah, just open these parentheses,
yeah,
like you usually do.
Oh, bx plus 2b over.
But it was b over 2, right?
Yeah.
So 2 times x times b over 2.
Where am I messing up?
So
2b over 4x. No, that's wrong. That looks really bad.
So she's saying to subtract the b over 4 in the equation above.
This one?
Yeah, so x plus b over 2 squared, and then you put on the other side
Oh.
b over 4 plus c. Is that correct?
Yeah, that's right.
All right.
Okay. I was just a little confused.
Make sure it's
And do you understand why it's b over 4?
yeah, because you square it to get
because
it
you
out
scored
of the
this
parentheses.
to get it there. Yeah.
Yeah, and when you square it, you basically added b over 4, so you need to subtract it.
Yeah.
Right. Okay.
Okay, good.
Thank you.
Yeah.
I guess I'll put this on that side. Makes more sense to me. Oops.
You pulled the
Yeah.
There you go.
And then you would equal this equation to 0, right?
Yes.
You need the squared on the
That too.
after the parentheses. You don't need it after the b over 4.
Oh, that's right.
There you
That's
go.
right.
That's good. All right.
Okay. So now we have x plus b divided by 2 squared and then plus. So would this just be c minus b fourths?
Mm-hmm.
Or does that work?
Oh, so the thing that is missing here, in your equation you said 0 equals x squared plus bx plus c, but where is a?
Oh.
Oh, okay. So A is supposed to be on the outside, correct?
Yeah.
You factor it out.
8.
No,
No.
you would divide all of the equation by a.
That's right. That's right. You're right.
Okay.
I messed up.
Okay.
There. That looks.
Yeah, that looks better. And then the next one will be b a. Wait, bx over a you have, right? And so you would multiply by 1/2, and it will give you b over 2a.
B over 2a.
2a. And then you would erase a in front of the parentheses.
Yeah.
Oh, just like that?
And then what do you need to subtract?
So that would change to B over
Subtract
2a.
B over 4a.
4a, you're right.
And also, so it should be b squared, right?
Oh, yeah. B squared over 4a. Okay.
Yes.
Over 4a squared.
4a.
Because you are squaring b over 2a.
Oh, and the a, you're squaring the a as well. Okay.
Yeah.
But the 4 already gets squared. Okay, I got it.
Okay.
So then we can change this.
That makes more sense now.
How then would you simplify this?
So you need all x's to be on one side and all the numbers on the other side. In order to find x's, right?
Right.
Yeah.
So we'd have to expand this, wouldn't we?
Yeah. No, but we found complete square in order to then find square roots of both sides. Remember, like we did in the last example.
So could you subtract this whole quantity and put it on this side then, where the 0 is?
Yes, exactly.
Alright. Alright. That makes sense.
This would be negative. Oops. Probably make that a negative and that a positive. And that equals
X plus B over 2a squared.
okay. Makes sense.
I'll put the squared on the outside.
Yeah.
On the outside, oh, you're right. Put the square
Yeah.
on the outside. Right. Okay. And then
So you could get rid of the exponent by square rooting it.
yes.
Square root the other side.
So that would have to be this and this. Get rid of that. And then you could subtract this over
B over
here.
2a, yeah.
B divided by 2a, b over 2a.
And that would be negative b over 2a.
Oh, yeah. B over 2a.
And then that's what x equals. Wow.
So on this one, you could find common denominator and then like add them together. Do you think that is under square root? Also, when you're taking square root of like just a number, you would put plus minus in front.
Yeah.
That's right. So where are you saying we need to find the common denominator then?
Yeah, to simplify this whole thing.
Inside the square root.
Oh, between these two, right?
Yeah.
Yeah,
Take
yeah.
the.
Right. Okay, that makes sense.
Yeah.
That makes sense. Okay. So to find a common denominator between these two, it looks like you have to square and multiply this side by 4. Yes.
Yeah.
Negative 4c divided by 4a squared.
So you multiply it only by 4, but we have just a. You need to multiply it by 4a in order to bring it to common denominator.
Oh, so it would be 4ac.
Yes.
Negative 4ac, and the bottom would still say 4a squared.
Yeah.
Because then you have to have the common denominator, and then you'd combine the two somehow, correct?
Yeah.
And this would be plus b squared. Yeah, right.
Yeah.
Okay, whoops. Alex, right. Okay. Yeah. Equals x.
And there is minus b over 2a.
Yeah, and you still have to add.
Oh, the minus b over 2a.
And now try to see if we can simplify it even more. So we have in the denominator 4a squared, and it's whole thing under square root.
So you could get rid of these squares, both of them, and get rid of the square root.
Yeah. Yes.
You would get rid of the 4a squared, which will be just 2a.
Like that. Does that not get rid of this squared too, or no?
No. You can't get rid of the denominator because there is just minus. It would be b squared minus 4ac, right?
Yeah.
But on the denominator, there is 4a squared. And square root of 4a squared is just 2a. So you could get rid of the square root of in the denominator.
Okay. So can we simplify this any further?
You would put square root in front of minus 4ac plus b squared.
Okay. Yeah.
And then in the denominator, there should be 2a.
So b squared over 2a is what she's saying.
B squared over 2a.
No. Just the whole thing is over 2a.
Oh,
because
okay.
this is our denominator.
2a.
Okay.
Then it's going to be. Let's see.
No.
No, there's something wrong with that.
No.
So
Go back to what it was.
AC
Yeah, put back.
plus b squared all over 2a, correct?
Yes.
Yeah.
Then instead of having the 4a minus b, it'd be a 2a right there.
So just that.
Mm-hmm.
So you'd keep the minus b, or would you get rid of the minus b?
No, you keep it.
Yes. Then it would just take away the 4a and just put a 2a.
Oh, like that?
Yeah.
Mm-hmm.
Oh, okay. And then, oh man.
So much harder.
So I don't know if you can see. Do you see something?
Yeah.
This is what we had, and then we pushed this number to the common denominator to get 4a squared in the denominator. So we multiplied c by 4a,
Uh-huh.
and we would get over 4a squared plus b squared over 4a squared. And so we've got the common denominator, and then we would push it under one common denominator, which here will be just 4a squared. So we have minus 4ac plus b squared.
Oh, I see it.
And then we would take the square root of this thing, which will be just 2a. And then this thing also, it stays the same. And so at the very end, here will be 2a, and here is 2a.
Mm-hmm.
And then we would put square root of minus 4ac plus b squared minus b, and the whole thing is over 2a equals to x, right?
Mm-hmm.
I don't know if you can understand.
Mm-hmm.
Let me see. Okay, this is still a little confusing.
So do you see?
So minus 4ab. A second, let me get that.
It's 4ac over b squared all over 2a minus b over 2a.
Yeah, and when there are common denominators, we can just subtract the denominator, right? So at the very end, it will be
Minus
just
b plus or
b.
minus square.
minus b.
At the very end.
Then there was plus minuses, so plus minus 4ac plus b squared over 2a.
So then, yeah, so b plus or minus negative 4ac plus b squared all over 2a.
So that's the quadratic formula.
Yeah, that's the quadratic formula.
So we were just working.
Oh my God.
Blown.
So we were trying to.
That's why I told you at the very beginning that you could either use quadratic formula and you would find the answers, or you could complete square and then find the answers.
Gives you the same answer either way, though. Oh my gosh.
Mind equals blown. Holy cow.
That's how the quadratic formula was found.
Oh, I remember my algebra teacher used to make us do this, and I hated it so much. Derived the quadratic formula. Yeah.
Oh my gosh. Yeah.
Jeremy, I
Okay.
think your mind is blown too, huh?
A little bit, yeah. But it connected finally for me.
I know.
There we go.
Because we sort of had the answer at the beginning and we were overcomplicating things.
Yeah, exactly.
That's basically what happened.
I think it's just so much harder without having numbers there. Like if you had numbers, I think it'd be easier.
Yeah.
At least personally.
Definitely.
But I don't know.
So what would the x-intercepts be then?
Our answers. Plus, you see we have plus minus. So those are our two answers. Two exercises. And then, so we equaled this whole equation to 0. So we substituted instead of y 0. So our points will be our answers for x, and then instead of y, we'd put 0.
So, okay, so it'd be negative b plus option b
square root of 4ac.
And then you could put it b squared minus 4ac. I mean, it's the same, but
Oh. Oh, just B. Or no.
B
Other one.
squared all over 2a. You're going to make sure you have a parentheses in between.
Right there.
Yeah. Just to make sure.
Not super confusing.
Yeah.
And we can copy that over here.
And then just trade it for
and then change that
minus.
sign to a minus.
Yeah.
Oh my gosh.
Yeah. So our answers were the quadratic formula.
Yeah.
Oh man.
I told you that at the very beginning.
Yeah.
Yeah.
And I remember now that we've gone through all of this.
But it's good. Now you like understand for sure
Yeah.
Yeah.
why those are the answers.
Yeah. First,
So
who in the world is that supposed to tie up together? But now I get it.
Yeah.
Awesome.
So I guess the intercepts would be v equals negative.
And it even says what would be the given, or what is the y-intercept for the given quadratic equation, of course.
Mhm.
Gave the answer.
Oh my gosh.
This one is easier.
Wait a second.
What am I
Wouldn't it
doing?
just- wouldn't
So
it
remember
just
when we
be-
were trying to find x-intercepts, we equaled y to 0. And now they're
Yes.
asking us to find
Right.
y-intercepts. So what do we need to equal to 0?
Basically, it's going to be,
X equals 0.
Yes,
So
exactly.
so then it's just going to be parentheses 0, comma.
it'll just be A. A is our y-intercept. 0A. Is that correct? I don't know. Thinking.
So when you put instead of x 0 in the quadratic formula, it would be a times 0 squared plus b times 0 plus c. And
Right.
anything a times 0 will disappear. It will be
Right.
just 0.
So it's just 0 comma C.
Yes.
All right. We
Oh,
just have one y-intercept and it's 0 comma C. Okay.
Holy
That's
cow.
easier. Okay.
Yeah, this one is easier.
That's just using the rule of a quadratic equation with C equaling the y-intercept. Right?
Yeah. When you need to find y-intercepts, you would equal x to the 0 and then put
Right.
it into the equation you're giving.
Right. But the given C is the y-intercept. That's just something I remember from
Okay.
the past. I don't know. It's weird. Anyways.
hmm. So what needs to be done to the function f of x, x 2x to the fourth minus 5x to the third plus 6x squared minus 15x before you can use the rational zeros theorem to find the x-intercepts?
Do you just factor out an x? Because there's one you can factor out.
Do you?
So what does the rational zeros theorem say? By the way, you were right.
All right. So you have to have a number without an x on the end. You have to have it down to the to an equation that has everything that can't be factored.
You have to have something that's basically a like C on the
Yeah.
equation of, where it doesn't have CX, it's just C.
Yeah.
So on something like that, how would you add? I don't want to say add, but input in a C, so then you could get all the rational zeros.
Wait, what'd you say?
Like right there, you would have to factor out all the x's or factor out. I don't know. I don't know where I'm trying to go. Oh well.
No, keep going though.
So like
Yeah.
I think I know what you're trying to say.
it's like you have 2x to the fourth minus 5x cubed plus 6x squared minus 15x. But then you have to have like a c, basically something at the very end that doesn't have an x attached to it.
Right.
Would you add? I don't want to say add in a c.
So you would just factor out the x, and it would create a minus 15 on the end, and you'd just have an x on the outside of the parentheses.
Okay,
Just
gotcha.
drop all of the. You drop it to a cubed, a squared, and just a regular x minus 15.
Okay, that makes a lot more sense. That's easier enough. Okay.
All right, cool.
Thanks, man.
Yep.
So I guess we're actually going to do that now.
Oh, okay. Find all the real and imaginary zeros for this function. You might want to change it back to black.
Yeah, that's true.
All right.
All the real and imaginary zeros. Wait a minute. Do we want to complete the square then on this one? Maybe not.
Is there a square to complete?
Don't think so.
I
I don't
don't
know.
think so either.
So remember how in the preparation we tried to find roots? No, possible zeros.
Yeah.
So I guess that's what we need to do here. Because it's asks us find all the real and imaginary zeros. For the function.
We're just gonna do the same thing we did earlier with the synthetic division. Or
So is there a faster, simpler way?
Just find the zeros first.
Find the zeros. Okay.
They're asking us only for zeros, right?
Yeah.
Yes.
For all real and imaginary zeros.
Hmm?
For all real and imaginary zeros.
Yeah, in our preparation class it asked the possible rational zeros, but here it is asking for all the real and imaginary zeros. So
Right.
Who knows the difference?
So in order to find the real zeros, trying to remember how to do this.
Same.
Oh boy. So we would just put y to 0, correct? And yeah,
Yeah, I
just
believe.
put y to 0 and solve for x.
Yeah.
All right, that's simple enough.
Okay.
Wait, how'd you get the extra x out of the equation?
Oh, did I miss that? Sorry.
Yeah.
Sorry about that.
So in order for the 15 to pass through, it would have to pick up the x again. So
Yeah. Oh, that wouldn't work, would it?
it
It would have just
could.
out of the parentheses.
Can you repeat that?
Pick it up.
I'm coming to get something to eat.
Yeah, give me 10 minutes.
Sorry, I really didn't catch that. Can you explain that to me again?
So we've got to take. I believe we've got to take the. Did you take the 15 out? I'm not.
So we're looking to solve for x.
Mm-hmm.
And in order to do that, we'd have to simplify it to what we can.
Uh-huh.
And so you also have to factor out an x from all the coefficients. Then it'd have to be like the same equation you have up top, where the x is factored out. But then to get the negative 15 out of parentheses, you have to apply x. So you have to multiply it by x. And so then when you move it over to the other side, it would be negative 15x.
So
Or no,
you would just
positive 15x
yeah.
equals x inside the x
times 2x
2x cubed 5x squared plus 6x.
Mm-hmm. So that that makes
And then
sense.
you start dividing.
When you cross it off, you divide by x on both sides to get rid of the x.
Oh, that works.
That would be 15 equals 2x cubed. But you could take out another x.
Yeah, so then you take off the x off of 6, and then you take off an x on negative 5x, and then the 2x would be 2x squared instead of cubed.
Okay, and then you can subtract 6.
Subtract 6, and you just have to keep.
You remember you have to keep the x on the outside.
Yeah, so the x will stay on the outside of the parentheses.
Wait, no, you have a you could FOIL that from the.
Oh, you could.
Yeah. You could finish the square. You still have to put the x on the outside, but you could FOIL it from there. Or whatever we want to call it.
What do you mean foil it?
So like simplify the binomial or whatever. Is it a bi or trinomial? I can't remember.
I think it's a binomial.
Alright. Yeah.
Did you have two? Well,
2x squared
so
minus
basically,
5x
so it would be
plus 6. So you'd have to
it'd be 2 on the outside of the
2. You'd have to factor out 2. Give you -5 over 2x plus 3 minus 2 plus 2.
So, so you equaled this whole thing to the 0 when it was x, and then open the parentheses to x3 and things like that. So remember the theorem when you have x and multiplied by some x minus 3, x minus 2, what did you do? It was in a preparation.
Oh.
This is the, I'll tell you which theorem. Zero product theorem. Remember when I said that when x times x minus 2 or times x minus 3, some of these like products should equal to 0 in order to get the 0, right?
Mm-hmm.
So 2x cubed minus 5x squared plus 6x minus 15, it's like a product.
All right.
And x is the other product.
Mm-hmm.
All right. So in order to get that, we have to have 2x cubed minus 5x squared plus 6x equal 15 to create that to make it 0. Is that correct?
You could equal each of the product to 0, which will give us x equals to 0, the first root. Then the whole thing to x cubed minus of x squared plus 6x minus 15 equals to 0 too. And then we would solve this big equation to get all the other roots.
Okay, I understand.
So would you put zeros in as the x's, or
No, because that's how you find the y-intercept. You're solving for y equals 0. So with this multiplication problem we have right here with x on the outside, x equals 0, and then we take the other problem and we solve that for 0.
Yeah.
So 2x cubed minus 5x squared plus 6x minus 15 equals 0.
Oh.
And then x equals 0. Yeah, I understand what's going on. This is crazy.
It's just zero product theorem. Like it says,
Yeah.
if A and B are algebraic expressions, then the equation A times B equals to 0 means that A equals to 0 and B equals to 0.
Mm-hmm.
In our case, algebraic expressions are x and 2x cubed and all these things. So we would equal x to the 0 and then this whole equation to the 0 too.
So x would equal 0, 15, 2x squared minus 5x plus 6 equals 15. Subtract. So with that, you could add the 15 to the other side.
Sure.
And then
Now we would use the other theorem, which was rational roots theorem. Remember, you were trying to find all the possible roots, and then you made the table, and
all right.
and then
So do
you do
the
all this.
synthetic division.
This thing?
Yeah.
Yeah.
So we would take that one and do that with that. Okay.
Boy.
So let's find possible roots first.
All right. So we've got.
So for the possible roots that I found, I have the leading coefficient is 1 and 2. And then for the constant term, I have 1, 3, 5, and 15.
Mm-hmm.
And so all of my possible rational roots would be 1, and these are all plus or minus. So 1, 1 half, 3, 3 halves, 5, 5 halves, 15, and then 15 halves.
Awesome.
And that's all plus or minus for all of them. So
Mm-hmm.
I just do a plus or minus in front and then put all those in parentheses so you don't have to go through and do it again.
Yeah.
That's true.
And then with that. No, just do 1 plus or minus at the beginning and then put parentheses around everything.
Put parentheses around all of your
Yeah.
factors.
Yeah.
There you go.
Oh,
And
wow.
then is that all we have to do? Would that be all of our possibilities, or do we need to then go and do the table?
Yes, so I believe we have to plug these into the equation, right? And we put it in for x, and so.
Yeah.
All right.
So I think we could probably just do the whole numbers first, since that'll be easiest.
Mm-hmm. Do we just each want to take a section and try working it out? Or,
Yeah.
so I can take the 15 and the 15 halves if y'all want to take the others. And then that'll be positive and negative. Just want to divide and conquer. Would you guys be up for that?
Sure.
All right. Wouldn't the third number on there be 6?
Yes.
Just double checking.
Yeah.
Yeah.
And then it would be 2 minus 5, 6 minus 15.
-5, right. Yeah, you're right.
Nice. Cool. And then whatever your number is on the left-hand side of that bar is whatever number you're plugging in. Is that correct?
Yes, that's correct.
All right. Just making sure. All right, I'll do
You good.
15 and 15 halves then. 2.
I guess I could do the 5 and 5 halves.
What 2 numbers do you want me to do?
Who said that?
I guess I'll do the 3 and 3 halves. Is that taken?
No.
Alrighty.
No.
To make sure I'm doing this right, you take the outside number and you multiply it by the top, and then you add those, or do I have that wrong?
I'm kind of
So you take the outside number and you add it, or you put it on top, or on top of the bottom section, and you add it to the next number, and then you put that number you got and you put it on the next section, and you add it, you put it on the bottom.
I thought you
Is
had to
that correct?
multiply somewhere. Don't you have to multiply
Yeah.
this somewhere?
Don't you have to multiply
Yeah.
6 by 5 and then... No, that's wrong. Oh, I can't remember.
I remember you had to multiply and then add, and that's where I'm getting confused because I wasn't sure where you're supposed to multiply and then add it at.
You multiply at the top and then you get your answer. Trying to remember now.
Let me look it up real quick.
Yeah, I think that's what it is. I'm not sure.
So you drop the first one. Oh, so you drop down the first number, and then you multiply the outside number by your first number, and then put it in the second. So your first number should be 2. So where you have 5 and 6,
Mm-hmm.
you delete your 5, and then you drop down your first number. So your 6 should be 2. No, you don't put anything there.
Oh, you don't put anything right there. That should be 2, right?
Yeah, and then you drop your 2 down, and then so that would be 2 there, and then you go 5 times 2, and you put that answer up there.
Right here.
So that'd be 10,
And
and then you subtract your 5, which would be 5,
5 times 5 is
and then
25.
you do that, and that'd be 25, and then you know, and then you add it,
Yeah.
and then you multiply and then add, multiply and add.
Oh,
If I'm correct from what it's looking like.
What the?
so that would be 31.
Yeah, it'd be 31. You're right.
And then
Oh,
9 times minus 15, 140.
yep.
Is that what that is then? That's how you do synthetic division.
I believe so.
Yeah, it's how you do, but you need to find such number that at the very end it should equal to 0.
All right.
So we know that 5 is not a viable option.
Yeah, it's not an option.
So we need the last number to be a remainder of 0, right?
Yes.
In order for it to work.
I don't think 15 is gonna work either. It's way too big of a number.
1 doesn't work.
Yep. No way. 15 doesn't work.
Yeah, you could erase those numbers.
All right.
So 15 doesn't work?
Nope. Gets you to like over 1,000.
1 doesn't work.
I would assume that negative 15 wouldn't work either. And then
Do you think it might be 3 then?
Let me try.
could be.
I haven't tried that one yet first.
Oops.
So neither 3 or 3/2 work.
Negative?
Neither of them work.
Did you do negative? Oh, 75.
I'll need to go
My
soon,
guess is
so
probably the only one that would work is 5/2, because if 15/2 is too big, and you know, 15 is
It's
too big,
5/2.
15/2
Yeah.
would be too big. So I'm gonna assume it's probably 5/2. It's the only one that'll work.
that's right. Let's try 5/2.
5/2. Yay, 5/2. Five.
That one works.
Oh, it works.
Your last one will be 15 minus 15, or negative 15 plus 15, so it would be 0.
Awesome. So this is our second root, 5/2. And then what do we need to do? Who knows?
Okay.
So what coefficients did you get when you did 5/2?
Oh, for my numbers, I just put them into my phone. Sorry, I didn't really write them down. I just did them in my phone.
Oh, okay. Let's do then this thing for halves to find our coefficients.
So 5/2 times 2 is 5.
Mm-hmm.
Yeah.
Then that would equal 0. So then your next one would be, is that 6? I can't see. Yeah, so 6.
Mm-hmm.
And then 6 times 5/2 is 15.
Wait a minute.
So that's 0 underneath the 6.
Okay. Yeah.
You've got 6 down below your 0.
Yeah.
And then 5/2 times 6 is 15, which gets your positive coefficient to equal 0 down there.
Right. Okay. Sorry about that. There we go. Okay.
Awesome. So our new coefficients 2, 0, and 6.
Okay. Are those the zeros then?
Yeah, but you only need to put one for your coefficient.
What do you mean?
So you had 2x cubed minus 5x squared plus 6x minus 15. And then we did this synthetic division in order to reduce the power.
All right.
And so now we are left with x squared plus some x and plus c. And our coefficients are 2, 0, and 6.
2, 0.
So we need 2x squared.
Right.
Yeah, that's 2x squared plus.
So that'd be 2x squared plus 0x, which is 0, plus 6.
Yeah, plus 6. And then you would equal it to 0. And now you're trying to find roots of this equation.
Square root of 3 equals x.
Square root of 3 equals x.
Yeah.
Let me just check.
Because you divide 6, or square root of negative 3. So.
Yeah.
I squared 3. Then.
Oh, yeah, you're right.
Negative
You're right,
6,
you're right. You're right. X would be, get rid of that. And then x would be the square root of negative 3, right?
Mm-hmm.
And don't forget plus minus square root of negative 3.
Yep. So it would be plus minus I square root 3.
Yeah.
All right.
So your roots are 0, 5/2, and then plus or minus I square root of 3.
Oh my gosh. Square root 3.
Would it be the 5/2?
5/2.
Oh, so not 5/2.
Yeah, because This is our root that we found in synthetic division.
There, yeah. So there they are, right there.
Awesome.
And then explain the difference, if there is one, between x-intercepts, roots, zeros, and factors. Use definitions, examples, graphs, etc. in your explanation. Well, x-intercepts are just where the line or the graph crosses the x-axis. So
Yeah.
And then I looked up on the root, since it said we could use definitions. It says the root of a number x is another number which can be multiplied by itself. So I don't know how else you would want to write that.
So how does that?
Well, it says multiply by itself a given number of time to equal x.
Multiply by itself a given number of times to equal x.
Yeah, to equal x. And then it gave an example where square root of 9 is 3 because 3 times 3 equals 9.
So, example, square root of 9 equals 3 because, okay, 3 times 3 equals 9. And then the zeros. I'd want to explain the zeros.
Okay, I need to go now. I'm meeting with the other group. But
Okay.
you did an awesome job.
Yeah, thanks for your help.
And you're the very last question.
Mm-hmm.
All right. Good luck,
Thanks.
guys. Bye.
Bye. Okay, so roots, zeros.
It says 0 here. It says 0 is a function, or let's see. The 0 of a function is an input value that produces an output of 0.
Is an
Input value
of a function.
Yeah, input value of a function that produces an output of 0.
That produce. And then for a factor. Factors
are numbers we can multiply together to get another number. That's what it says.
Wonder what that.
Which is true, because 2 times 3 equals 6, 1 times 3 equals 6.
Number
3 times 2 equals 6.
and factors are numbers that you can multiply to get the same result.
No, it's another number. Well, I guess, yeah, that'll work. That'll work. It makes sense that way, too.
You said 2 times 3 times 2 equals 6, and 1 times 6 6 also equals 6. Okie dokie. So that looks like that'll be the quiz. And I don't mean, okay. I'm going to save that GHOA week 3. Save that to the desktop to submit later. And I don't want to prolong the suffering, but in fact, we have some other things to do. If we can. Yeah, so it's just these 3 problems, and we're done.
Well, no, because that's in the preparation, right?
No,
So
this is
the preparation is doing yourself by yourself before
That's right.
the
That's right. You're right. You're right.
The only ones that if we needed to, which I don't know if we'd need to because we couldn't have done them all already, is the extension problems.
I think we're good. What do you think? What do you think, guys? Do you think we're good?
But we've done the rational roots theorem on multiple occasions, and we've also done
We've already done the
vertex
quiz,
X and Y
so
domain. The only one that I could possibly see doing would be number 2 in the extension problems.
Okay, might as well do it, right?
And that's just find the maximum height above ground level for the ball. At what time does the ground hit the ball? Or the ball hit the ground?
that's just finding the vertex, though, right?
Yeah, so you're just trying to find the vertex on that one.
Why don't we do it just for the sake of doing it?
Do it for kicks and giggles, right?
Kicks and giggles. Okay, so we have this parabola right here.
So you just gotta find where
The vertex is.
where it hits the maximum. So
Find the maximum height. And at what time does the ball hit the ground?
alright.
Which would be 0.
So that's when height equals 0.
Yes. So when does y equal 0 essentially?
Yep. That's for what time does the ball hit the ground, yes.
So the maximum height above the ground level for the ball.
That just means we have to put that into
Vertex form.
the vertex form, yeah.
Man.
Oh.
Yeah, I'm drawing a blank. Oh, right. Nope. Help me out here, guys. I'm drawing a blank. How did you put it in the vertex form again?
I believe this one you can use negative b over 2a, and then you just plug in b and 2. So you do negative 80
over
divided by 2 times negative 16.
Yeah, negative 32.
Negative 80 divided by
2 over negative 16.
over negative
2
16.
times negative 16.
No, times negative 16. Sorry, my bad.
Yeah. It's just negative 32.
At the end?
No, so it equals that's your what is it? That's your
Negative 40
x value.
times negative 16.
Well, no. So you do the 2 times negative 16 first, and then you put the negative 80 over that.
So it'd be negative 80 over negative 32, and then we have to simplify the fraction.
Yeah.
Oh, I got it now.
So that would be.
So you could divide that
positive, but if you divide that by what?
By 10. If you divide that by just 10,
by,
knock the zeros.
No, negative 32.
Oh, 32. Dang it.
Yep.
Almost.
And so you've got, divided by 4, you've got 20 over 8.
20 over 8, and then divide that by 4 again,
you
which
can
would
divide
get
it
you
by
5
8.
halves.
Yeah.
5 halves. Okay. And then what do we do with that?
You plug that
So
back
that's
into the equation.
That's your
So
X
that's your
for your
X.
vertex.
That's your time value. So you plug that in for T, and then you'll get your height.
Yes, now we got to do negative 16 times 5 halves
2.
squared.
Oh, man.
I'll just do that on the calculator real quick.
Sounds good to me.
I'll just plug that in. -1/6 times 5 divided by 2. Is 4 plus 80 times
Plus 12. I got 112.
plus 12. Yep, 112.
So our vertex would be 5/2 and
5 halves.
Yep.
Yeah, right. 5 halves.
112. And then you put h equals 0 and you find the time.
So now it says what time. So the maximum height, I believe, is 112
Sure.
Mm-hmm.
because that's your y. And we have to find that, so you can just punch that in. Maximum height is 112.
Well,
Oh yeah,
dude,
maximum height slash.
Well, it's asking for what our maximum height would be, and so just as an answer, your maximum height is 112.
Oh yeah. So yeah, maximum height would be 112.
112 of those feet.
Keep your vertex though, so we can remember it. So we'll need the 5/2 again.
There we go. Excuse me. Ugh.
And so take that.
Do you want to plug that back in?
Plug what back in?
So we want to set this equation equal to 0.
Yes.
So now we gotta find the time, right?
Yeah.
Yeah. So we want to know what t is.
So there will be two answers for that.
We have to pick the logical one, I think.
Mm-hmm.
Whoops. Did I miss something? Yeah, I missed a t right there, didn't I?
Yeah, you need a t squared and a t.
So time is distance divided by speed, right? So do we have a speed? So it's
No.
80 divided by your 80.
Initial velocity of 80 feet per second, yeah.
So our distance would be 112 divided by 80, right?
Yeah.
Is that correct?
That makes sense to me.
Yeah.
That's
So give us a
112.
fraction again.
Yes, it will.
Well, maybe. Did I do that right?
Could be this, possibly.
Well, maybe I put the numbers in wrong. Hang on.
Should be 6 over 4. Should equal 3 over 2.
Well, I'm not sure if I did that right because I just checked the answer and it says 5.515 seconds. So I'm not sure if I hit the.
Distance equals.
Oh, but it says they throw it from a rooftop that is 12 feet above the ground, and so if it's hitting the ground,
Right.
we have to factor in the 12 somehow. But I don't know how to do that.
Right. So the 12's already factored in with the plus 12 as the y-intercept. It's already over there. So if we just plug in 0 for.
Well, actually, I wonder what we do because it's distance divided by speed. So do we have, since the maximum height is 112, and you're hitting the ground, that's 12. So would we do it from 124 then? Or no? Would it be from, does that make sense? What I'm trying to figure out in my brain.
It does. That makes sense. 1 second. I gotta plug my laptop in.
It didn't work. Either way I did it, I still got the wrong answer, so I don't know.
If we plug in 0 for y.
I'm just trying to find the x-intercepts because one of these is going to hit the... Maybe not. I don't know. We'll try it. We'll try the old-fashioned way, I guess.
Yeah, let's see.
T plus 80 plus 12 and then minus 12 equals minus 16 t squared plus 82 and then you want to factor out a t from this thing, right?
Yeah.
And
So it'd be negative 16t plus 80
yes,
equals t equals negative 12, and then negative 16t squared plus 80 equals negative 12. Do what we did earlier.
wait a minute.
So
What is that? Negative 16t plus 80?
yeah, and then you go from there. So you subtract 80 from that. Negative 92 divided by negative 16 equals t.
Negative 92 divided by negative 16 equals t. Negative 92 divided by negative 16.
5.75.
5.75, yeah.
So the answer.
5.75. Is that right?
Well, their answer is 5.15, but I really don't know how they got it.
Oh my gosh.
Let's check a graphing calculator. See.
Alright. I've got my.
But I'm about ready to call it good with 2 hours worth of math.
Yeah, that's what I'm saying.
Yeah.
I'm kind of okay missing this last one problem, to be honest with you.
Plus 80.
And I don't think we even missed this one because we've already done the group quiz. So as long as we submit the group quiz, we should be okay.
I think that's a fair statement.
I feel like it's a fair statement, yeah.
But
According to the graph, it's 5.1, so I don't know how they're getting that. Anyway, but I think that's quite enough. What do you guys think?
I think we're good.
Yeah.
I'm
So-
done for the day.
Yeah.
So, remind me again, who was that one guy that left early? Who left early?
James
It was
Moss.
James Moss, yeah.
James Moss. Okay. Okay. That works for me. Thank you all. I guess we'll
Yep.
see each other
Alrighty,
next
see you
Tuesday.
all on next
All right.
Tuesday.
Yep. See y'all.
Good luck on the quiz, the test.
Yeah.
And the chat.
Yeah.
Fun chat. We'll see you guys.
All right. We'll see ya.